Hello, this is Jim McKeith, and welcome to this Developer Skill Sprint Intro to NoSQL with MongoDB and FireDAC. This works across all our development tools, RAD Studio, Object Pascal, C++, Delphi, App Method, and it works on the platforms Windows and OS X. It does not work with Android and iOS because there is no MongoDB driver for those platforms. So if you want to connect to MongoDB from those platforms, you'd want to use something like DataSnap or EMS to create a layer of remoting in there. There's going to be more slides than usual in this. I want to start out by saying, just because I think this is kind of some new concepts, and I think the slides do a better job of explaining the concepts. So we're going to talk about what is NoSQL, what is MongoDB, look at some basic usage, and then look at FireDAC plus MongoDB. Not going to cover this in as much depth as I like, but if you want to learn more, Code Rage 10, planning to have at least one full session on this that's going to go into more detail. So check that out. You can register now at thecoderage.com. Basically, NoSQL is the answer to the question is, what would databases look like if they didn't use SQL? If they didn't have a lot of the concepts we consider to be RDBMS concepts, relational database management systems concepts. So they favor speed and scalability over these RDBMS features that we typically think of as a database. So it's really a concept or an idea of how to reinvent the database. There's a large variety of different NoSQL databases, and it means something different, all of those out there. So it's not really a standard. Not all NoSQL databases are compatible. Each one's going to be completely unique in and of itself. So that brings us to MongoDB. Now, if you take and you graph all sorts of databases or things you consider databases with along this graph here, with speed and scale being on the up axis and features being on the horizontal axis, you get this graph that looks something like this here. And so you start out with a service like Memcache, which is a distributed object memory cache. All it does is cache objects memory. Okay, very little features for querying and stuff like that. So hardly any features at all, just storing objects memory. And then on the right, we have a full RDBMS, like Interbase. Okay, so basically the idea is that you're trading off features for speed and scale between these two. So MongoDB basically tries to find that sweet spot between features and speed and scale. Okay, now scale is really the thing that sets NoSQL databases apart, is that they're able to be scaled so much that you can have replication and shards and all this great replication and scaling features. So it's not trying to say that all RDBMS is slow, but the idea is MongoDB allows for greater scaling and therefore greater speed. So what is MongoDB? MongoDB is a document-oriented database. Okay, so in MongoDB, documents are stored as name-value pairs in BSON. Now, BSON is basically a binary version of JSON. We'll look at that briefly in a little bit, but it can contain regular name values as well as embedded documents or arrays, which really reduces the need for joins. So in a traditional RDBMS, you'd have, one-to-many and many-to-many relationships and one-to-one relationships between these different tables. That's a relational database concept. In MongoDB, you don't have that concept. Instead, you embed the data in there. So really, you've denormalized your data into one document. So also, there's dynamic schemas in MongoDB, so there's no consistent schema. All records don't have to match the same schema. This allows you to really deal with much more complex data because it's unstructured. So what exactly is a MongoDB document? Here's an example of a document here. So first of all, this is in JSON. There's some subtle variations between what makes JSON and BSON, besides the fact that internally MongoDB stores the BSON in binary format instead of in a text representation like we see here. But so you'll notice the names are in quotes, the string values are in quotes, whereas numerical values are not, and everything's separated by commas. But also we have the square braces for phone numbers represents an array. So that array contains, in this case, additional embedded objects, just like residential address is an embedded object, fixed line, mobile, etc. are all embedded objects within the parent record. So this is more unstructured, more dynamic than you would typically see in an RDBMS. Let's look at some different vocabulary words here. So the idea of being a database is the same, but a table from an RDBMS becomes a collection. A record or a row becomes a document. And then a column is called a field. Now the rest of these have the same equivalent names, although I will point out that schemas are different. There is some concept of a schema in MongoDB, but it's not required in that you don't define the schema ahead of time. You just start putting data in the database. So a few notes, all documents have an _ID field. Okay, so they automatically get that. That is a unique ID for that document. So a collection exists as soon as the document is added to it. So as soon as you start to insert into a collection, the collection appears. You remove all the documents and the collection is no longer there. So a collection only exists when there's documents within it. So one note, and this is a conceptual idea, really not a hard, fast rule. But like I said, you don't need a schema. There is no schema that defines what the documents look like. But typically speaking, you're going to have some similarities between the documents. You're not going to put completely different types of documents in the same collection. A collection is going to usually have similar documents, and those documents will have some fields that are going to be similar from document to document, but maybe not all fields. And so that's where the no required schema comes in. Now, it's called NoSQL because it doesn't use SQL, but it does have its own query language, which is going to be different from NoSQL database to NoSQL database. And this is a very powerful language. It has complex logic, even has the ability to do regular expressions. We're just going to scratch the surface on what you can do with this. They have some good documentation, though, as far as what you can do with their query language. I just want you to know it's really powerful, really advanced, and there's actually things you can do with MongoDB that you really can't do with SQL database queries. So there's a few things it really lends itself to. Okay, so installing MongoDB is actually pretty straightforward. You just choose whether 32-bit or 64-bit. For Windows, they have an OS 10 install as well, which you can find out about. But I'm going to talk about Windows installation specifically here. The default environment, though, is C:\data/DB. Now, when you're installing, it doesn't tell you this. And when you finish installing, there is no shortcuts on your desktop or in your start menu. And so you have to go to their documentation actually to learn how to start it. But essentially, there's an executable called MongoDB, I believe it is. And you just run that, and that will start MongoDB. There's some options for that. So check out that tutorial, which is the first link at the bottom there. And that's on MongoDB, and that goes into details about how to start it. You can actually set it up to start as a service, so it starts automatically, or you can start it manually by running MongoD, and then use Control-C to terminate it, and it cleans up itself and shuts down appropriately. So now as far as FireDAC goes, we actually have some new units and new components. You see the new units listed there, and there's 4 components. We still use the FD connection, so that's not a new component. That's the existing FD connection you're used to with all your FireDAC connections, but it now has the ability to connect to MongoDB. And then from there, you have new components of a Mongo query, which is able to use that new MongoDB query language in order to do queries. You have a Mongo dataset, which is able to connect to a MongoDB cursor and store that complex data. And you also have the idea of a pipeline, which allows you to execute pipelines to collections, which is, we're not going to really get into today, but hopefully we'll get a chance to cover that in Code Rage 10. Beyond the components and units, we also have some low-level classes, and you're going to end up using these. So I'm just going to touch on them here, and then I'll show you some more in the code. You have the Mongo connection, and this is what manages the connections to the database. You also have a Mongo database, which you can get from the connection. You can say, hey, connection, what databases do you have, and get the connections databases out of there. And then within database, you have collections. And then within collections, you can then get a cursor, which when you do a query, you get a cursor back that you can use to iterate through that cursor. We have these new Fluent style builders. So Fluent, you'll see the example code it's a coding format, if you will, a coding style to build these updates or selectors or inserts, or indexes, etc. Okay, so now let's have a quick demonstration. The first sample I'm going to show you here is the JSON Workbench. Now, this you can use to come in and look at the code to see how it does things, but you might also use it as a utility. So this allows you to take a JSON document and beautify it by making it using some standard formatting. You can also minify it to remove the spacing, and then convert it to a Delphi string concatenation statement here. Probably the most useful, though, is that you can use the writer with builders to create a builder objects. This uses the Fluent builders to write out the JSON, kind of like we used to do with the DOM in XML years ago, except I think a lot cooler. So you can see here, you begin an object called glossary, and you add a title, example glossary, etc. So this is using the Fluent builders, which Fluent builders is, like I mentioned earlier, with the what we're going to use for like building queries and stuff like that, which I'll show you later. But it's just an example of that. So you can paste this into your Delphi application to create this object at runtime. And then here is where it shows you how it converts from JSON to BSON. So this is a hexadecimal representation of the binary representation of the JSON, and it will convert back again, which removes the spaces in the process. So you can come in here and take a look at the code. Most of the interesting code is in the converters unit here. So you can actually just copy the converters unit wholesale into your application. And if you wanted to convert JSON to JSON builder code, you just come in here and take a look at what it's doing to do that. Okay, and this is making use of the new system.json namespace. The MongoDB dataset demo shows you how to work with the FD Mongo query. A couple things to note about this. The 3 grids here each have their own data source, but the data sources are all going to be tied back to this one query because that query is going to contain nested data sets. If we go in here and look at this, we can see right here where the nested data sets are attached. So this has an address.coordinates contains the nested data set that we're attaching here, and the grades the nested data set that we attach to these 2 different data sources. Now, when we run the query, there's actually 2 different ways to use the query. You can use the query property where you pass in the tmongo query, which you build using the Fluent builder, or you can just pass in the match. Now the match is going to take a JSON string that it's going to look for documents that have matching field names and values. So it's going to look for any document that both has the field names listed and the values provided for those documents. Now if you use the QMatch, which is where you pass in that matching JSON element, then you can also use the QProject and QSort. Now QProject is for the projection, which is going to be where you specify which fields of the document you want to come back, and the QSort is where you specify the sort of the output. So let's go and take a look at this running. So if I run this, it's going to fetch restaurants that have a cuisine of Italian and address zip code of 10075. Now notice that it's address.zip code. That's because address is an object, embedded object in the restaurant document. So the address has these sub fields here. And so to specify the zip code, we specify address.zip code. Now again, here we have the embedded arrays, and those are embedded down here in these other grids. So we can see all the values there. And if I was to click on one of these, I could actually bring up the dialog there as well. Now, a couple notes about this query syntax. I can actually use a different format here where I say address.zip code is equal to the value of, and then I specify an object here equals 10075. Now this is going to run exactly the same. See, nothing changed. It just went back to the first record. But the interesting thing here is I can actually change this now. Instead of saying equals, I can say not equals. And then there's other operators you can do there, like less than, greater than, so on and so forth. So there's, this is a simple format to the syntax, just using the name and value, but you can also expand this with logical operators and so on and so forth, including regular expressions. So in SQL, we would use a like statement, so this like this, and here you'd use a regular expression to say, I want everything that matches, contains this regular expression. Okay, so that's a really quick intro to using the JSON query component. Now the Mongo basic demo shows how to use some of the low-level objects. So on the form, we have our FD connection that connects to the Mongo database. Now internally, we cast that to a tmongo connection. So the client object here gets connected to a Mongo connection. And that's what we're going to use to deal with it here. So for example, inside the insert, we're going to go to our connection, specify our database within the connection, and then within the database, we specify which collection we want to work with, the restaurants collection, and remove all. So it's going to remove all documents from the restaurants collection in the test database. Then we're going to build a new object in here to insert. So ODoc is a tmongo document, and we build it here using this Fluent syntax. So it has an address field, and the address field contains these fields within it. So it's an embedded object. And then when we're done, we go down here and say to the connection, we say test restaurant insert the document we just created. So that's how you do an insert. Here's an example doing a find. This is actually going to do a insert first just so there's data defined. And right here it's building a find, so dot find, and we say we're going to match. Here we're doing again building the object using the fluent syntax. So we're going to match f1 is greater than 5 and end object. So that's our match, and then here's our sort. And then, as I mentioned, your query can have 3 parts, which using query syntax or objects, or using the QMatch, QSort, and QProject. So I can actually add a project on the end of this. Here, that would be project right there. I could then build a project, which would be the projection, which specify which fields I want to receive back. And then also you can specify a limit. In this case, we're going to say we only want to receive 5 back. So that's a quick example of how you would use the fluent syntax to build a find, which is how you would query to find documents within a collection. So for more information, check out mongodb.org. That first link is to the installation guide, as I mentioned earlier. The second link there is to their documentation, which is pretty good about explaining CRUD introduction, CRUD creating, reading, updating, and deleting documents from within a collection. And again, you don't have to ever create collections because a collection exists as soon as you put a document within it. DocWiki link there explains how to connect to MongoDB. There's a link to the samples folder. They're currently only Object Pascal samples. There's no C++ samples, although at least at the higher level working with the components, it's going to be very, very similar. There's very little code you have to deal with. It's just like you would work with any other data set, except with the variations I showed you there. A couple books here I'm recommending. The first one, Instant MongoDB, which is a short introduction to MongoDB that has a chapter that covers installation, and it covers like what are the key things you need to know about MongoDB. So if you don't want to read a lot, that's the one I recommend. If you do want to read a lot, check out MongoDB, the definitive guide. It's the definitive guide for MongoDB, or at least that's the goal. Contains a lot more detailed information about MongoDB. Instant MongoDB is available through Packet Press, which is the one that publishes the Delphi cookbook as well. And MongoDB is available through O'Reilly, which they also have the Delphi in a nutshell from a few years back. So both of those are available. I got those as ebooks. Check that out from O'Reilly.com. Also, if you want more information, Code Rage 10, available October 13th to the 15th. Register for that at thecoderage.com. Next time, David and I is going to talk about Delphi anonymous methods and C++ lambdas, when to use them and when not to use them. Register at embt.co/sprints15 with a capital S, which is next Tuesday, the 22nd, at the time you see there. Allow me to quickly tell you about some of the special offers we have going on right now. As part of our early bird pricing, if you purchase RAD Studio, Delphi, or C++ Builder 10 Seattle, you can save 10% on your license if you purchase by September 30th. Also, registered users of any earlier version can qualify for upgrade pricing. This is a savings of up to 45% off new user price. Update subscription is not required, but still recommended, and everyone also gets access to the free bonus pack. The free bonus pack includes the new book by Nick Hodges, More Coding in Delphi. This covers topics like writing solid code, duck typing, and multi-threaded parallel programming. You also get the new book by Marco Cantu, the Object Pascal Handbook. This is a modern language guide that covers the new features in Object Pascal, as well as some of the core runtime library. The MITA Converter Basic automates some of the conversion of a VCL application into a FireMonkey application, so you can take advantage of multi-platform application development. Also included is the VCL and FireMonkey Premium Styles Pack. This includes styles for both desktop and mobile for VCL and FireMonkey that allow you to really make your application stand out and give it that premium look and feel you want. To find out more information about the bonus pack and these special offers, visit embarcadero.com/radoffer. And now it's time for questions and answers. But here's learning resources for you one last time. If you go to the Sprint NoSQL MongoDB short link there you see at the bottom, that will take you to the blog post, which does have learning resources on there. So the question here, where can I find the JSON Workbench demo? In the samples folder. It is there. I did update all my samples from the Subversion repository, which I recommend. I'll add a note to the, I think there was some things specifically that changed on that one and someplace else that definitely want to make sure you have updated those. So I'll put a note in the sprint -NoSQL -MongoDB blog post. Let me put a link in here to that in the chat window. I usually do a search to find where those are located at because I can't always find the samples. So just do searching in the directory to find it. So David's asking, says different documents in the collection don't have to have the same schema, so there's no guarantee of data consistency. Why and what's the benefit? So that's kind of the, I guess, the $6 million question, if you will, about why you'd want to use NoSQL databases. Is there really, it's a different way of looking at databases. And so if you don't, chances are some people may not need them, but probably at some point you will come into contact with some sort of project where you do need them. But the idea is that sometimes you have complex data, and so the example I gave is, let's say you have a product catalog, and some things in the product catalog are going to have different data available for them. Like, so for example, you might have clothes, and clothes have sizes, and then you might have cars, and cars have miles per gallon, and you might have computers, and they have different specs for computers. And so in a RDBMS, you'd have to figure out ways to normalize this data, right? So you have a product catalog that's going to list and say, oh, this is a product type, so it's going to this product has a product type of car, and so product types of car link to this database, which contain details about cars, and so on and so forth. So it gets really complicated to try and normalize that data into a traditional RDBMS because there is so much inconsistency between the record types. Okay. So that's where NoSQL and MongoDB comes into play, is that you have these complex objects, these objects that have variations and differences between the different records. So yes, they can be different. Now, when people talk about the features of MongoDB, they're like, oh, there's no schema, you don't have to have the same consistency between records. Well, the reality is that would be totally useless if there was no consistency. Well, mostly useless, let's say. So the reality is that typically there is some consistent fields. And so this, again, is where the functionality of requiring those consistent fields, where there's some thought put into the design of this to say what fields need to be consistent between documents, is pushed out of the database and onto the developer's shoulders in the application that interfaces with it. So you need to still make those decisions and say, you know what, we need to have these fields need to be consistent, these fields need to be there, and react accordingly and develop accordingly. So by not putting that functionality in the database, it's able to speed up MongoDB's performance. So I'll put in a link to where to find the JSON Workbench. It's also on SourceForge, so David, thank you for that. So James is asking, what are the advantages of MongoDB over Interbase? It's one of those things, there is not a better database. You can't say, oh, well, Interbase is better or MongoDB is better. They're different databases. They're different ideas about how to deal with that question of storing data. Interbase is a fantastic RDBMS. It's fantastic for storing that normalized data where you're able to normalize it and say, this table, you know, has exactly these columns. This table has exactly these columns. These tables have a many-to-many relationship, so on and so forth. So that's what Interbase is good at. MongoDB is good at storing documents, where documents are defined as these collections of name-value pairs stored in JSON. And so where you're storing, if you're storing data that has consistency between records, then Interbase is a great solution. If you're storing data that doesn't have consistency between records, then MongoDB is a better solution. So it's kind of like the question of what should I use, char versus varchar in my traditional RDBMS, right? So you use char if all of your strings are roughly the same length. If they're not roughly the same length, use varchar. So you can think of Interbase as being char, whereas MongoDB is the varchar because it's able to deal with these complex record types or complex document types that are not consistent from document to document. Hopefully that answers your question. Again, like as David summarized it, they're different animals. Actually, I was in a session one time where someone was learning about MongoDB or NoSQL databases in general, and they're like, well, I have a using an older system, or I'm using an RDBMS now and it's too slow and I want to speed it up by switching to a NoSQL database. No, that's not the answer. You cannot switch from a NoSQL or a SQL database to a NoSQL database just to get speed improvements. They're completely different animals. They solve the problems differently. Andrew's asking, maybe an impossible question, but what would you say was the sensible practical limit for a MongoDB database size, either in terms of number of records, megabytes, or terabytes? I'm going to go with that's impossible for me to answer. You could probably do some research and find out if there is limits out there. As I alluded to, one of the things about MongoDB is, and NoSQL databases in general, is that they're able to scale tremendously. So it could be that they just have to have more, or it could be that NoSQL databases have a much higher upward limit than you would see with other databases, which is saying a lot because I've seen some really huge RDBMS databases. So yeah, I don't know what the limit would be in megabytes, terabytes, or number of records. Again, as I mentioned, you'll want to join us for Code Rage 10 because I'm planning to do a full hour-long session on this where I'm going to go into more detail, and actually I'm going to reference this session and say, hey, if you want an intro to MongoDB, go watch the skill sprint. But in this session, we're going to go into some more detail and learn a lot more about the details of MongoDB and hopefully get into things like pipelines and aggregates and stuff like that. So lots of good stuff. I'm excited to see MongoDB support built into FireDAC because it's a neat, powerful database, and it's nice to have because it's a different answer, right? It's not saying, hey, let's start out with, I mean, for RDBMS, right, it's easy to say, I'll start out with MySQL, but then when I need RDBMS features, I'm going to switch to Interbase, right? And you can say there'd be this upgrade path that you would go through to switch databases. But MySQL is, or I'm sorry, not MySQL, but MongoDB is a completely different animal, so it's a different choice you make. If you're trying to pigeonhole data into Interbase and it doesn't fit because it's too complicated and there's too much variation from record to record, chances are you want to use MongoDB. Andrew's saying, so if I visualize MongoDB as providing a sort of persistent multiple properties bag, is that a fair description? Yes. Yeah. So you can think of, now was some of the first NoSQL databases were they're called like my object databases and stuff like that, where it was just the idea of, hey, I have an object, programming object that I want to persist, and you just persist it to this object database, and it would store it. And so that's really what MongoDB does, is where you have these objects that are have multiple properties to them, and you want to just persist them and then query for them later. So that's what MongoDB does. It does have the concept of creating indexes, so you can decide which fields within the documents you want to index, which will, since some documents won't have that field, they won't get indexed. So you want to choose what fields the documents will have. So like I said, there's no requirements that collections have consistency, but you're not going to store a, I'm trying to think of an example. You're not going to store an address record, an address document in a collection that contains employees, okay? You would store an address document embedded in an employee document within the employee collection. So hopefully that makes sense. Does MongoDB return a data set as a query result that can be further queried? Pat's asking. It's actually that's a good question. I would believe so. I haven't tried it. You could use, because MongoDB does with FireDAC. So it's just interesting, actually. FireDAC does a really good job of taking MongoDB and then bringing it into the FireDAC concepts we're familiar with, like a data set. Okay, everybody else is working with MongoDB. They don't have data sets. They just have these lists of objects, JSON objects, and then they have to work with them that way, which is fine for some things. But it's nice that with FireDAC we can get this MongoDB data set, or the MongoDB query comes back as a data set. So then we could, in theory, take the client SQL components that are also included in FireDAC and run a SQL query against a MongoDB dataset. I haven't tested that, but it should work because it is a dataset at that point. So yeah, I think you should be able to do that, Pat. That's a really good question, and maybe I can get a chance to cover that in Code Rage. Lars is asking about supported platforms like mobile support. So currently there is MongoDB drivers for OS 10 and Windows, and probably Linux as well. So there is not MongoDB drivers for Android or iOS. So if you're wanting to connect to MongoDB from Android or iOS, you're going to want to use EMS, Enterprise Mobility Service, or DataSnap. So there was a little confusion. A few people came in and said expecting for the skill sprint, and they weren't expecting MongoDB because the title of the series is what was it again? The Developer Skill Sprints, Code Test, Version Control, Deployment, and More. So that's the name of the series for this quarter. So the and more is the MongoDB today. So kind of exciting. I'm really excited about MongoDB. I think it's a great new feature to have to see a whole new paradigm for the way we work with databases available through FireDAC.
But you also had code.
What's that? Oh, yes, that's true. There was code in there, wasn't there? So, yep, this was code. Jens asked, this is, does MongoDB support transactions and referential integrity? So, those are very distinctly RDBMS features, and part of the idea of MongoDB is to move away from some of these features. So the way it supports transactions is it supports transaction at the document level. And so at the document level, you can have a transaction. So that means if you're updating two different documents or two different collections at the same time, you don't have referential integrity across that transaction. Now, in a database, a typical RDBMS, you have normalized data, right? So you have your customer, and your customer has addresses, and the address is in a different table, and they have phone numbers, and the phone numbers is a different table. And so when you're updating all of those, then you need the referential integrity. Now in MongoDB, you only have the one document that has that embedded into it. So it has the address object embedded into it. It has the phone numbers embedded into it as an array. So you have a referential, or you have an update transaction on that update to that document. So you're updating the entire document. So there's some things MongoDB is not good for. For example, if you're needing to do transactions, like for example, banking and transactions, this is the classic one, right? You got to take money out of this account, put money in this account. You can't embed those two accounts within each other, so therefore you can't have a transaction that supports updating two different documents. So does not have that support. Now MongoDB does have the concept of references. You can have a reference to an object. So every document has that underscore ID, so you can have a reference to it in, let's say, object, and then have that number in it, and that reference to the object in another collection, possibly even. If you go to that blog notes, embt.co, there's a link to a YouTube video that shows how to use ER Studio with MongoDB. And if you watch that video, it's only 5 minutes long. It will show an example of a schema, and it shows both the logical and the physical representation of that schema, and it shows the idea that you have a address embedded in different tables. So you have, I'm trying to remember what they have, but they have like the idea of a patron and an author, I think it is, and both of those have addresses. And so it shows that, hey, these are addresses. In this case, is a one-to-one. In this case, is a one-to-many relationship. But the reality is, those objects are embedded in those other documents. So, and it also shows the idea of references, where it's referencing an object. So you can take a look at that video, like I said, 5 minutes long, and it explains that. So yes, it does have references. I do not believe it has any referential integrity. It doesn't have the concept of cascading updates and cascading deletes and stuff like that. So again, it has some of them, but not all of them, because they're trying to find that sweet spot between all of the features in RDBMS and being able to speed things up. Jens is saying, is MongoDB supposed to be an alternative to embedded stuff like SQLite? Okay, so MongoDB is not. So there is no MongoDB driver for mobile devices like on iOS and Android. And I'm trying to think if they have the idea. I'm not sure if they have the idea of an embedded version of MongoDB, but really MongoDB is its objective is to be massively scalable. so that you can scale it across multiple machines, and you can have in order to achieve a lot of speed for handling a lot of data, a lot of input and output. So in that case, it's not really targeted at an embedded database type system. It's more embedded at, or targeted as distributed, where you're going to have lots of servers running MongoDB and then replicating it across to that. Yeah, so you have to install the embedded. You have to install the MongoDB server. Like I said, I didn't see anything about an embedded version of MongoDB. So you do install it, and then that is what you connect to. Really, if you wanted to have MongoDB as an embedded database, really at that point you're creating a hash table. I mean, that's basically what it is. You have a hash table of objects in memory, and it uses B-tree indexing in order to help you find things. So you could create a B-tree index on a property of your object in order to be able to index it, and then you could just search through that. Oh, you're welcome. Yeah, this is pretty exciting. I'd looked into document databases, NoSQL databases previously, and it was pretty cool. And then it was great to be able to just dive into this again and to see the great way that FireDAC supports this. And I didn't even get into a lot of the more advanced FireDAC features because I really wanted to focus on the changes in concepts from RDBMS to NoSQL, and to be able to get started with that. So yeah, FireDAC provides a huge level of functionality. The cool thing is that you get that data set back from MongoDB. Everybody else that's using MongoDB doesn't get the concept of a data set back. They only get back the list of objects. So because you have that data set, you're able to do more data set-like operations. So it's really the best of both worlds with FireDAC and MongoDB. So the question came in here is, which one is better, SQLite or MongoDB? So they are fundamentally different types of databases. You can't make an overall comparison of which is better. Now, for some tasks, one is better than the other. For if you want to have normalized data, SQLite is great. If you want to have denormalized data or data that's not a consistent schema. So an example that you oftentimes see with a good use case for MongoDB is the idea of a product catalog. Okay, so a product catalog, you might have one product that is clothing, and clothing has sizes and colors, right? And then you have another product type that is automobiles. Automobiles have miles per gallon and a entirely different set of information about them. So if you try to normalize all these different types of products into a traditional RDBMS like SQLite or Interbase, that would be a lot of work. I mean, okay, this is the products table, and it contains a car, and then it has a product type, and it says product type is car. Okay, product type of car means we're going to link it to this other table over here that has all the information about cars in it. And then we link if it's clothes, we're going to link it to this table over here that has information about clothes in it. And it's going to be a lot of work to try and create that, store that in a normalized way. With MongoDB, on the other hand, you don't have to do that because you can have each document within the collection, within the product collection, can have a different schema. It has a different set of columns, or different set of fields. So, and it can have embedded data within it as well. So you can store this kind of complex and not standardized, not normalized data within a collection in MongoDB. So depending on your use case, one is going to be better than the other.